Here in section 2, we're going to continue talking about radical expressions. In particular, today we're going to look at simplifying radical expressions, becoming familiar with how radicals work and things of that nature. So the first property we're going to look at is the product property of radicals. And what this property says is that if you're looking at the square root of a times b, that can simply be rewritten as the square root of a times the square root of b. Okay, so for example, if I give you the square root of 9x, you can rewrite that as the square root of 9 times the square root of x. Alright, well, you know what the square root of 9 is. The square root of 9 is 3, and then the square root of x just says we don't know what that square root is, so we just leave it. Okay, so in example 1, when it says simplify the square root of 12x squared, that's the same thing as saying the square root of 12 times the square root of x squared. Well, the square root of 12 can be broken down now into the square root of 4 times the square root of 3. And we all know that the square root of x squared is just x. Well, we know what the square root of 4 is now. We have 2 square root 3 times x. And what we usually do is we'll bring the constant and the variable all the way out in front of the radical. And so we'd rewrite this thing finally as 2x square root 3. Okay. Some of you guys might be familiar with this as, you look at the 12 and you're breaking this thing down using your factor tree. You can do that if that's what you prefer to do. Okay. Same idea. So in example 2 part A, it says multiply each set of radicals. So square root of 8 times the square root of 2, that's just the square root of 16. And we know what the square root of 16 is. That's just 4. In B, now here's where you got to be careful. If something's underneath the square root, you can multiply them together. If they're outside, you can't bring it inside. Okay, so you can't go from inside to outside or outside to inside unless you know the square root of something. So for example, in part B, this 2 right here is going to stay all by itself out in front. So you have 2 square root. Now underneath that square root, we have this 5. So we have 5. And then I have x to the third times x, which is x to the 4th, and then we just have a y. Okay, and I'm going to go ahead and make sure we have all that over there. Well, I look underneath the square root. I know what the square root of x to the 4th is. The square root of x to the 4th is just x squared. So I have a 2 out in front. Since I know the square root of x to the 4th, the x squared comes out in front. All right, and then left underneath the square root is just your 5y. That's it. Okay. And that's what we're looking at. Okay, let me go one more page. The next property we're going to look at is the quotient property of radicals. Same idea now, except now you're just dividing. So in other words, the square root of a over b is the same thing as the square root of a divided by the square root of b. Okay, so the square root of 4 over 9 is the square root of 4 divided by the square root of 9. Well, that's just 2 over 3. All right, and you're done there. So in example 3, part A, simplify each radical. I'll do part A. I'm going to leave part B for you. So this guy we would simplify down to the square root of 11 divided by the square root of 49. All right. Well, that's fine because I know the square root of 11 is on top, but I know the square root of 49 on bottom is just 7. And so your final answer would be 11 over 7. All right, rationalizing the denominator. We've talked a little bit about this already this year. When you're working with radical expressions, you cannot end with a square root in the bottom. And so in part A, I got to get rid of this square root 5 on bottom. And so what you do to rationalize is you multiply the top and bottom by whatever that square root is that you're trying to get rid of. I want to get rid of the square root of 5, so I multiply top and bottom by the square root of 5. And so now what happens is on top you have the square root of 2 times the square root of 5. That's the square root of 10. All right, and the square root of 5 times the square root of 5, the square roots just cancel, and all you're left with is 5. Another way of thinking about that is if you were to multiply these two things together, you would get the square root of 25, and that number is just 5. I apologize. I'm going to take a second to try to figure out if I can get the pens to stop doing what they're doing. All right, anyway, I don't know if that worked or not. We'll find out. So in part B, I got to rationalize this. So I got to get rid of the square root 7r on the bottom. So I'm going to multiply the top and bottom by the square root of 7r. Okay? We're just going to have to deal with it. Sorry, guys. Okay, so when I do that on top, I have the square root of 7r, and on bottom I just end up with 7r, and I'm done. I can't really simplify that anymore. Okay, so part C, you should be good to go on now on your own. Adding and subtracting radicals, what you do is you treat the radicals just like they were variables. So for example, in part A, I see 7 root 5 and 4 root 5. Since they both have root 5 in them, I can combine them. So 7 root 5 and 4 root 5, that's just 11 square root 5. The square root stays the same. You just add the coefficients. Minus square root 11. I can't break it down anymore. And so all I do is leave it. Okay, sorry about that, guys. I'm not really sure what's going on with the pens right now, so bear with me here. In part B, I can't combine anything because you'll notice this has a square root of 2 in it. This has a square root of 11 in it. I can't do anything there. Okay, so I'm done. There's nothing to be done. In part C, you might be thinking the same thing. I see the square root of 11. I see the square root of 44. But what you have to remember is this square root of 44 can be broken down. Okay, so I have 3 square root 11 plus 2. The square root of 44 is the same thing as the square root of 4 times the square root of 11. And I know what this is. That's just 2. So this is equal to 3 square root 11 plus 2 times 2, which is 4 square root 11. And I can take that down one more step and call it 7 root 11. All right, so that's what we're looking at when we're simplifying, when we're adding and subtracting radicals. Okay, the last example is it's multiplying. So again, I'll do one example here and then let you guys roll with the rest of it because it should be pretty straightforward after you see an example. If I give you part A, you're just going to FOIL it out just like we've done in the past. So we're here, and then we come here. And so you end up with 4 times 3 is 12. I'm going to erase this because I really can't see what's going on right now. I'm not really sure what's going on with my marker, so I apologize, but we'll take any questions that you have in class. So anyway, you end up with 12 minus 4 root 3 plus 3 square root 3 minus, and then you have root 3 times root 3, which is just 3. And so your very last step is to simplify. Well, I have a 12 and a minus 3, so that's just 9. And I have a negative 4 root 3 and a positive 3, so that's a negative 1 root 3. And really, we don't even need that negative 1 out in front. Okay, we could have just left that in there. So again, in parts B, C, and D, you're just going to use the distributive property and or FOIL method and just getting familiar with how to simplify radical expressions. As always, I know this video is probably a little bit confusing because A, my markers weren't working very good, and B, I realized that I skipped a slide there. So I apologize for kind of the helter-skelter, so to speak, video here, but hopefully it gives you at least a brief understanding and glimpse into what we're talking about when we talk about simplifying radical expressions. As always, bring any questions that you might have to class, and we'll make sure we handle those first thing.